Yes, so I'm Darko. I'm a software engineer at Celtra, and I'm working from Ljubljana office. So Ljubljana is the capital of Slovenia, and Slovenia is a small country in the Central Europe. So I'm not from here. I'm currently only on a visit, and I am also working from our New York office. So anything else?
That's good.
Okay, I can start?
Yeah, go for it.
Okay. So just a few words about Celtra. So what are we doing? We are actually working in the digital advertising. So we are making a tool for creating ads. It's kind of like a Photoshop for the ads. We also serve these ads. So we serve them on the mobile web, on the desktops, on the in-app environments. So we try to support as many environments as possible. We also have tracking inside of our ads, so if somebody clicks, swipes, plays a video, pauses a video, etc., we track all of these things. And based on that, we also have the analytics. But today I'm not going to talk about our product. I'm going to talk about replacement of CSS animations with JavaScript animations in our platform and the reasons why we decided to do this in the first place. So as I've mentioned, users can build interactive ads with our tool. And it was actually really, really important for us to implement this feature, this animation system, right? So we came up with a list of requirements for our animation system. And the first thing is that we needed to support complex animations. So what do I mean? I mean, we wanted to animate multiple properties at the same time, so position, rotation, scaling, etc. And we also wanted to animate multiple objects so they don't get out of sync, so they have to stay in sync. This was really important for us. The second thing is that we wanted to support multiple animations. So the first one being the animations driven by time. Let me show an example of such animation. So this is it. So an animation is played according to time. So we say at 0 seconds the ball has to be here, at 1 second the ball has to be here, etc. And then an animation engine takes care of everything else. The second thing are the animations bound to scroll. So this one, and let me show a demo. So it's actually quite simple. When we scroll a page up, the animation progresses. And when we scroll a page down, the animation moves back in the opposite direction. And if we're not scrolling, the animation stays still, okay? The third type are the video progress animations. Unfortunately, I don't have a demo for this because this is still in development, but it's pretty simple to understand, right? So we have one video and one or multiple animations bound to that video. And when the video is played, an animation is played, and when a video is stopped, an animation stops. So, for example, you could add some small effects to the video or subtitles or something like that. We also wanted to be able to play and to seek through the animations in our ad creator, so in our Photoshop for the ads. So let me show that. I will explain this a little bit more into detail later, but we wanted to be able to do this, to seek and to play the animations in our builder also. And last but certainly not least, since we are in the digital advertising, it's important that our ads work on as many environments as possible. So we wanted to support them on as many mobile web and desktop browsers. And all of these things bring quite a lot of complexity. And let's try to dig in with this animation. So as we can see, this animation is actually built out of two animations. So the first one is the left to right animation, which is linear. So the ball is moving from left to right linearly. And the second one is the position Y animation. And this one isn't linear, but it is eased in and eased out, and this gives a ball this bouncing effect. So when we combine both of these animations, we get this bouncing ball animation. And the important thing to note here is that we have two different easings. So we have linear easing and we have ease in and out to give the bouncing effect. Just to show you quickly how would we build this in our ad creators. So this is the timeline for our animation, and as we can see, it has a 5-second length. Here we have also the markers for the second. And on the left, we have the animated properties. I'm not sure if you can see them, but here is the position X, position Y, and also the rotation. I didn't mention the rotation previously because it's not important for this example, but it just looks cooler, so I added it. Okay, and we have these squarish things here. These diamonds or what are actually the keyframes. And as you can see, we only have 2 keyframes for the position X animation. So this one, when the ball is at the far right, and this one, when the ball is at the far left, okay? So for the position Y, we have multiple keyframes. So the first one is this one, when the ball is at the bottom. Now the ball is at the top, at the bottom, etc. So it's pretty simple, and at the end, we repeat that animation. We loop it indefinitely, and we get the animation that I showed before. Okay, and this animation actually looks pretty simple, but it's not so trivial to implement on the web, okay? Let's take a look at some of the issues connected to the reactive animation. So these are the animations connected to scrolling. So this one. Okay. So the first thing is that the scroll speed can change, right? So if a user suddenly starts to scroll faster, an animation has to be played faster, and vice versa. The second thing is the inertial scroll. So this is the scroll that still continues when a user lifts his finger, right? So when a user flicks, and a scroll still continues, an animation still has to be played during that time, okay? And both of these things are made even worse if we have multiple keyframes with different easings, right? And there are quite a lot of considerations, as we have seen quite a lot of issues to solve. And these are not so trivial to solve on the web, right? And our first intuition was to use the CSS animations, and we did a research, okay? Just a second, I'm thirsty. Okay. So we researched 3 types of CSS animations. The first one are the CSS keyframes animation. And if anybody isn't familiar with them, they're actually quite simple. We define the keyframes with CSS styles at certain progress. So for example, 0%, we define the starting keyframe with some CSS styles. We defined another at, I don't know, 5%, 10%, etc. And we define the final state at 100%. So the key here is that we only define the keyframes, and the CSS animation engine then takes care of the entire animation. So we just set the keyframes, the duration, the easing between the keyframes, and then the CSS animation does its magic, okay? Web Animations API is actually really similar to the CSS keyframe animation, but the difference is that we define the keyframes in JavaScript. And the second difference, much more important one, is that we get some additional functionality compared to CSS keyframe animations, which I will describe later. We also researched CSS transitions. So we just defined the animated CSS properties on the CSS transition property. We are going to focus mostly on the first 2 because CSS transitions are intended for simpler animations. Okay, so let's take a look at some of the issues that we discovered during our research. The first one being animating the position, right? So if we animate the position with left and top CSS properties, what is actually going to happen is that the animated pixels are going to be rounded to the whole number. So what this actually means is that the animation is not going to be visibly smooth. And let me show a demo. I hope it will be visible. So as we can see, we get this like kind of stair-stepping effect. So an animation is not smooth. Okay, so left top, smooth animation, we get an X. We can solve this if we use CSS transforms instead. CSS transform translate X, translate Y. And what happens here is that the animated layer gets pushed to the GPU, and then GPU renders the pixels at the edges with different intensity, right? And this mimics the effect of higher resolution. So I hope this will be visible here. No, it's not. But you can trust me that the animation is smoother here, so you can go ahead and check it. So we get a check mark here for transform, smooth animation, check mark, okay? But we have another issue with CSS transforms, and this is overriding keyframes. And let me try to explain that. If we go back to our bouncing ball example, we said that we had two different animations. So the first one was linear, and the second one was eased in and eased out, okay? And how would we implement this if we used left and top CSS properties? This won't give us the bouncing ball effect, but it's kind of a demo how would we implement two different keyframes with different easings, okay? So we would define, can you see it in the back row? You can? Okay. We would define two keyframes. So the first one would be for animating the X position, and we would just say start at left 0 pixels, finish at 200 pixels. And we would define another keyframe for animating the Y position. So in this direction, we would say start at top 50 pixels and finish at top 250 pixels, right? So one keyframe for this direction and one keyframe for this direction. Then here we have our animated object, which it is just a regular square. And we find it with our query selector, and we apply the linear easing to the position X keyframe and the ease in and ease out to our position Y keyframe. So we are basically saying animate this one linearly like this, and animate this one with ease in and out in the Y direction, okay? Am I going too fast? No? Okay, cool. So if we take a look at the example, what is going to happen? Oh no, I still have an old code. Let me refresh it. It's going to work, right? We get an animation in X direction, which is linear, and in Y direction, animation which is eased in and eased out. But we are not happy because, as we said, left and top are not smooth. So none of the keyframes get overridden, so we get a check mark there. But we are not happy still because an animation is not smooth. So we should use CSS transforms, right? We said that this would make animation smooth. So let's go back. And here is our example. And if we take a look, it's actually the same as the previous one. The only difference is that we are using transforms instead of left and top CSS properties. But we still apply the linear easing to the position X and ease in and ease out to the position Y, okay? So it's the same example, just using transforms. And let's check what is going to happen. This happens. So we get only an animation in the Y direction. And why does this happen? What happens here is that the last set keyframe, so this one is the first set keyframe, and this one is the second and the last one. And all of the transforms that are set in the last set keyframes are going to override all of the transforms that are set in all of the previous keyframes, okay? So, and this isn't an issue in the animation engine. An issue here is that we are animating the same property. We are animating the transform in both keyframes. So this keyframe is then going to override this one. So we get an X here. So how could we solve this? We can solve this if we use transforms plus wrappers. So what we would do is, in the next example, so this part is still the same. These are some styles which are not important. The main difference here is that we added a wrapper around our square. So we have just one div element, which is a wrapper. And we again find it here with query selector. And now we apply the keyframes separately. So we apply the position X keyframe with linear easing to the wrapper. And we apply the position Y keyframe with ease in and out on our square. So we are not doing that on the same object as we did before. We apply those keyframes separately. And this way, they won't get overridden. And if we take a look, and this actually works, so animation is smooth, none of the keyframes get overridden, so we are happy, right? But the issue here is that our creatives, so our ads, we call them creatives, they support a custom JavaScript. So our users can insert a custom JavaScript, and if our users are relying on some HTML structure of our ads, and we suddenly started to add wrappers during runtime, this could potentially break their code. So this solution actually works, but not for us. Okay, let's move on. The second thing, when does the animation start when the main thread is blocked? What do I mean? If we go back to our left and top example, we start the animation by setting this WebKit animation property. So by setting this property, we say animation start, okay? And what we could do immediately after that, we could add 100,000 console logs. So just to keep the main thread occupied. But this could be anything. This could be some complex computation. This could be a synchronous request, anything, as long as it keeps the main thread occupied. So we are asking ourselves, when will the animation start? So if we start an animation here, what is going to happen is that it won't start here, but the start will actually be delayed to this point until the main thread is free again, okay? Does this make sense? Cool. So we get either a delayed start, or the second thing that can happen is that when we say animation start, it actually starts, but then it freezes on the first frame, and it stays frozen until the main thread is occupied, and then it jumps. And this jump is actually a compensation for the time when the main thread was occupied, okay? So either a delayed start, animation jump, or actually most often a combination of both things happens, right? And if we take a look at the demo, so I uncommented here our console logs. Let me refresh, and let's check what is going to happen. So we definitely got a delayed start, but maybe we, the animation jump, but maybe we also got the delayed start. I'm not sure. And why is this an issue? So if we would use CSS keyframes animation, we actually wouldn't know anything about this because there is no way to get the progress of a currently played keyframe animation. So if we got a delayed start, animation jump, we wouldn't know anything about this in our code. If we instead used Web Animations API, this would actually solve an issue because we can always query the current time of the playing animation, and we would know if we got the delayed start or animation jump, okay? Next issue, syncing multiple animations. Okay, so let's say that we have a scenario when we start the first animation, and when the first animation reaches 50%, we start the second animation, right? So pretty simple scenario. As I've said, if we use CSS keyframes animation, we wouldn't know when the first animation reached 50% because there is no way to get that out of CSS keyframe animation. But let's say that the first animation has a 4-second length. So this means that the first animation would reach 50% after 2 seconds, right? And we could do a workaround. So we would start the first animation, set a timeout for 2 seconds, and in the callback, play the second animation, right? This sounds like a legit workaround, but the thing here is that actually, the first thing, we are not sure that the set timeout callback is going to be executed after 2 seconds. So if queue is full, so if the set timeout queue is full, or if the main thread is blocked, it actually won't get executed after 2 seconds. So this statement actually means execute a callback in 2 seconds or more. So it's not reliable that we would start the second animation after 2 seconds. The next thing, when we start the first animation, as I was just describing on the previous slide, we could get an animation delayed start. So if we get a delayed start, we won't reach 50% after 2 seconds, but after 2 seconds plus the delayed start at the beginning. Does this make sense? Hopefully, okay. And again, when we start the second animation, the same thing can happen there. So we get a delayed start. We can get also a delayed start there for the second animation, and we wouldn't know anything about it if we use CSS keyframes animations, okay? We could solve this if we would use Web Animations API, but I mean, we can query the current time, but the issue here is that Web Animations API isn't supported everywhere. So it doesn't work on iOS Safari, it doesn't work on iOS desktop Safari, it doesn't work on Internet Explorer, of course, it doesn't work on the Edge. So it's a bad idea for us. Okay, the next thing, syncing animations with scroll. Okay, so this is relevant to these animations, right? And I'm going to talk about the case where we would solely rely on the CSS animations engine to do the animation. So what we would like to do is we would like to define the keyframes and let the CSS animation engine take care of everything. So in order to do that, we would have to generate the keyframes in advance when a scroll starts. And I mean, this even sounds like a stupid idea, but anyway, let's dig into it. So when a scroll would start, we would first have to estimate the scroll speed. And based on that, we would have to estimate the duration of the scroll. And based on that, we would then generate the keyframes in advance, right? If you want that CSS animation engine takes care of everything. But as I mentioned before, if you remember, the first issue is that the scroll speed can change, right? So what if a user starts to scroll slowly and then flicks at the end? This means that when a user flicks, the keyframes that we generated previously aren't correct anymore, okay? Also, the inertial scroll. We are not sure if an environment has an inertial scroll or not. And even if we knew that, we don't know what's the duration of the inertial scroll. We don't know its easing. We don't know anything about it. And we would have to estimate or guess all of these things when the scroll starts. And the key word here is estimate. So we would only get an estimation this way. We wouldn't get one-to-one mapping from scrolling to animation. And what we could do to solve this, we could generate the keyframes not only at the beginning of the scroll, but for example, on every 200 milliseconds, okay? So if we wouldn't get the keyframes right the first time, we would get them right probably in the next 200 milliseconds. But this would still be an estimation because we would still estimate all of these things that I mentioned before. We could do this even more frequently until we would do it on every request animation frame, right? But if we do that on every request animation frame, we are actually making an animation. We are not relying on CSS anymore. So it's not a good solution to use CSS keyframes animation for that. If we use, again, Web Animations API for this, this would solve the issue because we would just map the scroll to the current time of the animation. But again, Web Animations API isn't supported everywhere, so this wasn't a good solution for us. Okay, I already mentioned some of the differences between the CSS keyframes animations and Web Animations API. And here is the entire list of them. So we can pause, resume, and reverse the animations with these two properties. But at the time when we were implementing this 1.5 years ago or so, these two properties weren't supported everywhere. And even if they are supported now, we still have to support some legacy environments, so this isn't okay for us. We don't get any callbacks at certain progress, as I already mentioned, nor can we change a playback rate with CSS keyframes animations. And these things are all solved with Web Animations API. So we can pause and resume an animation with pause and play function. We can reverse an animation with reverse call or by setting a negative playback rate. We don't get callbacks at certain progress, but we could simulate that by polling the current time, and we can change a playback rate by just setting it. Here are some other CSS issues connected to sizing, which we actually can solve. The first one is that animating width and height CSS property with the text inside of it causes a text reflow. So what do I mean? Let me show a demo. It causes this. Okay, and we can solve this by using CSS transform scale. and it will look like this. So this is the desired behavior. The second thing is that an image becomes blurry when we upscale it, okay? And 1.5 years ago, this was still reproducible on desktop, but it's not anymore, but it's still reproducible on devices. And because of that, I don't have a demo, but you can believe me, it does happen. And in order to solve this, you can increase an image size before an animation starts and downscale it. So let me explain that. So for example, if we have a 100 by 100 pixels image, and we want to scale it 2 times, right? We wouldn't scale it from 1 to 2, but instead what we would do is we would increase an image size before the animation starts to 200 by 200, and then we would downscale it to 0.5. And we would animate it from 0.5 to 1 instead of from 1 to 2. Does this make sense? Okay, hopefully. Okay, so as we have seen, there are quite a lot of issues with CSS, and if we get back to our list of requirements for our animation system, we said that we wanted to build complex animations, to support multiple types of animations, to play and seek through animations in our builder, and to support different environments. Well, as I was just describing, this isn't possible with CSS animations, and because of that, we had to switch to JavaScript. And we implemented our own JavaScript engine, and this is how it looks like. So let me explain it. Everything starts here in our playback controller. And how does it work? I mean, the purpose of the playback controller is to calculate the progress of the current animation. So we have a different playback controller for each type of the animation. So for example, for the time animation, it converts time to percentage. So for example, if an animation has a 4-second length, we are at 2 seconds, it will return 50%, okay? Similarly for the scroll animations, if a screen's height is 1000 pixels and we are at 500 pixels, it will return 50%, okay? And similarly for the video progress animations. It then passes those 50%, for example, to our JavaScript animation engine. And what this animation engine does, it actually can generate transforms at any progress of the animation. So it can generate a transform at 0%, at 1%, at 99%, at 100%. And it also takes into consideration all of these keyframes that we defined. So this keyframe, it takes into consideration all of the keyframes and all of the easings in our keyframes. So this one has ease in, this has one ease out, this is linear. So the main thing is that it generates transforms, right? And it generates one transform per every animated object, okay? So in our example of bouncing ball, it would generate one transform, and this transform would have translate X, translate Y, and rotate, okay? We would then apply this transform to our ball, and we would repeat that on every request animation frame. So if you're not familiar with the request animation frame, it's actually like a callback that happens 60 times per second. So we get 60 FPS this way. So for example, in the next request animation frame, we are at 2.1 seconds. This outputs 53%. It calculates new transforms. We apply them again to our ball, and we repeat that in the next request animation frame. And this solves the issues that we were describing previously. So we said the first issue was the overriding keyframes, right? The thing here is that our JavaScript animation engine outputs only one transform, and this transform has all of the animated properties on it. So it has translate X, translate Y, scale, rotate, everything on one transform property. So we don't apply these properties on the separate keyframes. We apply them on the same transform, so there is no chance that they will get overridden between each other. The second thing was syncing multiple animations. So as I just mentioned, to be generate the progress ourselves. We calculate the transforms ourselves. We repeat that on every request animation frame. So basically, we are constructing the entire animation. We are taking care of everything. So syncing comes out of the box. So we are not relying on a CSS black box. We are making sure that everything works by ourselves. Some other interesting facts about our implementation. So we specified the keyframes in a very similar syntax as the CSS keyframe syntax. So we use JSON. We actually implemented a really similar functionality to other libraries. So other libraries exist that do the exact same thing. But the thing is that those libraries have a lot of additional things that we didn't need. So we implemented only the minimal functionality that we needed because in advertising, kilobytes matter. So we implemented just the minimal functionality. We also implemented our own functionality for pause, play, reverse, stop, etc. OK, what about the performance? We tested our animations on compute-intensive websites. So for example, on a really bad website like this with a lot of content. This was actually a testing website, one of the testing websites. And our animations worked smoothly. So we actually got a better performance with complex animations compared to CSS. So if we had an animation, for example, with 20 or 50 animated objects, the animation performed better than CSS animations. But the thing is that our clients are building mostly simple animations, and in those cases, CSS performs better. One performance candy, or how should I say it, is that we also pause animations when they're off screen in order to save battery. OK, so I'm not trying to say you should all switch to JavaScript. In the vast majority of the cases, the CSS is the way to go. But because all of the issues that we had, all of the complexity we had, all of the product demands that we had to switch to JavaScript. But in vast majority of the cases, CSS is the way to go. So that's it.
Yes. Are there any browsers that you guys just will not support? Is there anything that's too difficult? Or?
I mean, yeah, it's always Internet Explorer and the Edge.
Gotcha.
But other than that, I don't think so.
UI web views on iOS.
Oh, OK. The old web views on the iOS, maybe, yeah.
Gotcha.
For the JavaScript API, does that happen at the same time as request animation frame or at a different part of the loop?
Which part do you mean of the?
When it's actually doing the animations in the browser.
Yes, it happens on the same time. Yes.
Cool. Awesome. Well, thank you.
Thank you.